we will start our problem with a right-angled triangle which has one acute angle of 15 degrees. Then, using the hypotenuse of this triangle as a diameter, we will construct a semicircle, as you can see on the sketch, which has the area of pi. The question is, can we somehow calculate the area of this red triangle? This problem was sent to me by one of my subscribers, Andy from Texas. So thank you, Andy, for this wonderful suggestion. And if you guys want to try this one out for yourself, you can pause the video right now and then come back and check the solution. Alright, so let's solve this one. So first, let's take a look at our semicircle with the area pi. And let's say that the area of the semicircle must be 1/2 of the pi r squared, and we know that this area equals to pi. So we can start by simplifying this and multiplying everything with 2 to get the following. Then we can cancel pi on both sides of the equation, and we will get that r squared is equal to 2, which means that the radius of this semicircle must be equal to square root of 2. Now, let's take a look at our triangle. We can label its legs as A and B and the hypotenuse as C. But remember, the hypotenuse represents the diameter of our semicircle, which has the radius of r. So the hypotenuse must be equal to 2r, or we can say that hypotenuse is equal to 2 square root of 2. Now let's save this value for later, and let's take a look at the acute angle of 15 degrees. Now we're going to use some basic trigonometry. We're going to say that the cosine of 15 degrees is equal to the leg A over hypotenuse C, which means that A must be equal to C times cosine of 15 degrees. In the same manner, we can calculate the sine of 15 degrees as the leg B over hypotenuse C, which means that B must be equal to C times sine 15 degrees. Now we're going to take those two equalities and multiply them. Why are we doing this? Well, just take my word for it, you're going to see the reason really soon. If we do this, we're going to get the following. Now, we can simplify this to get that the product of A and B is equal to C squared times the sine 15 degrees times the cosine of 15 degrees. Now let's again do something strange. Let's expand this equation with 2, and in this way we will get the following. Now here comes the main reason why we did this in the first place. Let's remind ourselves of one really interesting trigonometry relation, which states that sine of a double angle equals 2 times the product of the sine and cosine of this angle. This is, of course, well-known trigonometry relation, and we can use it in our favor here. As you can see, in our equation, we have 2 times sine 15 degrees times cosine 15 degrees, and we can say that the value of the angle alpha is equal to 15 degrees, right? So this is the same thing as our trigonometric relation. So we can say that this equals the sine of 2 times 15 degrees, which is the sine of 30 degrees. So we can just substitute all of that value for the sine of 30 degrees, and we will get the following. Now, again using the trigonometry, we know that the sine of 30 degrees is equal to 1/2, and we can multiply both sides with 1/2 to get that A times B is equal to C squared over 4. Now, we're just going to substitute the value of C into our new equation and get that that is 8 over 4, and we will get that the product of A and B must be equal to 2. Now, remember, we're looking for the area of our red right triangle, and the area of any right triangle is equal to the product of its legs divided with 2. So, since we already have the value of a times b, we can just substitute this value, and we will finally get that the area of our red triangle is equal to 1 squared unit, and this is our solution. Well, I really hope you guys enjoyed this simple but really interesting mathematical problem. If you did, do not hesitate to leave a like or subscribe to the channel for more content like this. Of course, leave your comment down in the comment section below if you found another interesting way to solve this problem. And until next time, see you all and take care.